Okay, here we are. So a few words about myself. So I'm a senior lecturer at BTH and responsible for development and teaching cybersecurity courses. I've been also for a while working in the antivirus industry, analyzing cyber attacks, and during the recent years, we've seen many ransomware attacks. And in this presentation, in this workshop, I'm going to share my insights on defense evasion techniques. So probably you might ask yourself, okay, how come that with all these tools available on the market, cybersecurity tools, EDR, firewalls, CM solutions, how come that cyber criminals, they still have capability to bypass security perimeter of the organization and deploy ransomware and start the extortion campaigns. So you've heard probably that even the leading cybersecurity firm FireEye had been affected by the attack through SolarWinds Orion platform, which was supposedly run by a Russian Nobelian hacking group, which was attributed to Russian intelligence service. So during this presentation, I'm going to give examples of defense evasion techniques used in the most prominent ransomware attacks. So let's start. The first attack I want to highlight is REvil ransomware delivery using a Kaseya VSA server. So on the screen, you can see the message published in the data leak site called Happy Blog. So there is nothing about REvil, but for some reason they call this blog Happy Blog. And they say like, on Friday, July 2nd, we launched an attack on MSP providers, and indeed, they managed to deliver REvil ransomware through the update for the Orion platform, which was delivered to more than 18,000 of customers. More than 1 million systems were infected, and that's true. If anyone wants to negotiate about universal decryptor, our price is $70 million. So this is the highest demand asked by this cybercriminal group, and probably this is the biggest ransomware campaign run by the REvil. Just going a bit forward, that REvil currently is not active nowadays, and in September, Bitdefender released the decryption tool for the REvil ransomware. So if you know the organizations that have been affected, then it's possible to use a decryptor to restore all the files encrypted in the past. And as far as I know, FBI was somehow managed to get access to the command and control server of the REvil of the Nobelian criminal group and got access to the master key. And because the REvil was a ransomware as a service, they sell this piece of ransomware to the affiliates, and affiliates they own their own master keys. And these master keys were used to decrypt, to create a decryptor that were used to decrypt the files after a victim pays the ransom. But for some reason, REvil authors, they also have their own master key. And when the ransomware creates the session key on the affected machine, they encrypted the session key before deletion using the affiliate's master key and their own REvil's master key. And that's why actually not only affiliates were able to decrypt the files, but also REvil authors also were capable of doing that. And as I said, FBI got access to the server and got this master key, which could be used to decrypt these files. Just a small remark that REvil is not dangerous anymore. However, that was a quite sophisticated piece of ransomware created by the criminals, and they had also version for Windows and Linux platforms. And as you can see, they have like this master key, which could be used to decrypt all the files on all the in all the organizations, even though session keys were different on this, for these machines, and they were ready to sell it for $70 million. That was the highest price. So how the attack went on? You can see this is a photo made by one of the investigators from the victim's machine. This is a Windows server, and you can see Windows events log. And I would take a look at two events here. So the first event is running Kaseya VSA agent hotfix. So the ransomware was delivered under the guise of hotfix, like update, a critical update for Kaseya VSA server, which it wasn't actually, of course. And after executing this hotfix, they also run the task archive and purge log just to wipe any traces of the infection. And so just first insight on this defense evasion techniques. In this attack, the attackers use PowerShell script to disable Windows Defender services. As you could see, so here, this is a PowerShell.exe code, and then we can see the PowerShell script itself, the code of this PowerShell script, and the service is called setmp preference. And then we have like a bunch of options like disable real-time monitoring, disable intrusion prevention system, and so on. So all these parameters are used to disable different modules of Windows Defender service. Then you could see also how it deploys itself. So it uses a legitimate CertUtil. This is a certificate management tool. And the ransomware was delivered as an agent.crt file. So it's .crt stands for the type for certificate, but it wasn't actually a certificate. It uses decode command to extract agent.exe, which is a REvil ransomware file, from agent.crt. And then it deletes these files and leaves it in some specific place. Another technique used to bypass security solutions is using digital signatures. So that's actually not a new technique. So the idea is that the attackers, they issue digital certificates for some unknown or fake company, and then they sign executable files with this digital certificate. And antivirus solution, some of the antivirus solution, when they see that the file is digitally signed, so it means like it reducing the score, risk score of running this application. And in some cases, in antivirus, just skip scanning the file and just let this application run. On the contrary, if the file, unknown executable file is going to be run for example, in Windows, then security service blocks execution of the file if it's not signed. So I mentioned that is not a new technique, and we've seen this in LockerGoga attack against Norsk Hydro enterprise. Norsk Hydro is a top 5 aluminum manufacturer, and in this attack, the authors of LockerGoga ransomware, they used fake certificate, actually certificate real, but they were issued to some, unknown companies like Alisa Ltd, Kitties Ltd, Mikel Limited, AB Symbol Limited, and the certificate authority used to sign this, to issue the certificate, was Sectigo, which was seen many times in issuing such kind of certificates for attackers. So there is like a low verification procedure like not perfect verification procedure for each of this certificate. And another attack which was which was following LockerGoga was the Megacortex, and in this case the certificate were also issued to some companies that were registered to the address which you can see on the screen here in Romford, which is a suburb of London. And this is a place actually, if you open the Google map and try to watch, try to locate this address. And the interesting thing that more than 70,000 of organizations were registered in this building. Can you imagine? Of course, that's just a fake company. Another technique, by the way, which we study in our malware analysis course is DLL side-loading attack. The idea of DLL side-loading attack is when the attackers can use some legitimate executable file. In this case, this is AMS MPN. This is a executable that is used to run Windows Defender on Windows, and it's not actually the latest version, but the version from 2014. At that year, this executable file was susceptible to DLL side-loading attack, which means what this attack is about. It's when some legitimate executable file process loads the DLL without checking its integrity and authenticity, which means this DLL supposedly comes from Microsoft, but the process doesn't check if it's digitally signed, if it has valid Microsoft certificates. It just loads this file without any checks. And this behavior is exploited by attackers. So they just replace this original DLL, which is typically placed in the same folder with executable file, and put like malware, just renaming this malware so it looks like a legitimate DLL. And then they just execute this real Microsoft executable. It starts process, of course, without any problem, because the file is digitally signed by Microsoft. Even though it's old, it still has a valid digital signature. And then it loads this DLL, which is not original one, but just a rush by created by the attackers. So this happened in this case. So this is the properties of this Windows Defender executable file. As you could see, it was dated back to 2014. And this is the ransom node. So here you can see the price, the demand asked by the attackers. This is almost $45,000 per victim, or you can buy like a universal decryptor for $70 million. By the way, after time ends, so they usually use this social engineering like marketing techniques. So if the deadline ends, so you need to pay like $90,000. So the price doubles after expiring this promo time period. And it's interesting that immediately after running this attack, some other criminals, they started exploiting this fact of this event to run this phishing campaign. So they use a topic of like delivering security updates patches for Kaseya SVR server, and they share this. They send this phishing email where they propose to download the fix for this vulnerability, and as you can see, this is delivered as executable file attached to email. Of course, like I believe for most of the spam filters, they should have blocked this email. Well, if we talk about Kaseya attack, delivering REvil via Kaseya hotfix, so this is called attack. This attack is called a supply chain attack, which means the attackers, they exploit this supply chain to deliver a piece of malware to the target computers as a legitimate updates or hotfixes or whatever. Similar attack, not the same, but similar happened when we had NotPetya delivered through accounting software called Medoc in Ukraine. And it also affected Myers company from Denmark, which you probably heard in 2017, when the legitimate application Medoc was compromised and a backdoor was embedded into one of the DLLs. And once this update was released, the attackers, the criminals, they actually Russian hackers, they try to deliver different kind of ransomware. So you could see like there were multiple attempts to deliver like 4 different types of, at least 4 known according to our investigations, 4 types of ransomware, and the last one was delivered on 27th of June. It was NotPetya, which led to which led to destroying the systems all over Ukraine, and not only inside of the Ukraine, but in the connected networks as well. One more attack, interesting. WastedLocker is also sophisticated example of ransomware. So WastedLocker known to attack Garmin services. On 23rd of July, Garmin reported in the Twitter that we are currently experiencing an outage that affects Garmin Connect service. This is a cloud service used by all the connected Garmin devices. And as a result, website, mobile application are down at this time. And then later, like 4 days later, they report that they managed to fix the problem. Supposedly, they paid money to ransomware attackers and got decryptor and decrypted all the services, because it was not possible actually to restore all the servers in such a short period of time. So what's the story? WastedLocker is a ransomware operated by REvil Corp. By the way, REvil Corp is headed by Maxim Yakubets, famous Russian hacker. You can see it on the screen that actually Russian hackers in Russia, they feel quite free to live, to enjoy their life, and you see that they spend all this extorted money for buying expensive toys, like this custom Lamborghini, and they had they have a kind of like a club of fans of sport cars, and they do city drifting in Moscow with no problem. And you could see even a police officer just probably advising how to get to the place where they gather and do drifting. And the FBI also looking for him, and they have a reward, $5 million for his head. Let's get back to the attack on Garmin, which happened on July 23rd. So WastedLocker was used in numerous attacks against US-based corporations, at least 31 that refused to pay, and their data were published at the data leak site, and we know about that. The ransomware rise for Garmin case from $500,000 to $10 million in Bitcoin. So we don't know exactly whether Garmin paid or and how much. And what's is most interesting for this particular presentation is which particular defense evasion techniques they used in order to bypass security services. So you can see digital sign-in. Of course, it's probably the easiest and must-have defense evasion technique in order to be executed, allowed to be executed on the target machine. But next two techniques like alternate data streams and lazy writing, even though they have been used before by other attackers in other campaigns, but not very popular and probably not in this implementation. So let's take a look in more details at these defense evasion techniques. So digital sign-in, well, it's clear. In this case, we can see that the name of the company is really something strange, and I believe it is possible to create some, smart algorithm that would be capable of recognizing this fake company names and warn of executing the files signed with this, rush certificates. But more interesting thing is using alternate data streams. In Windows, operating system uses NTFS file system type, and it allows creating so-called alternate data streams, which means you have files in this file system, and for example, in this case, we have a file called join. But then you can create metadata for this file, which is not visible in this particular in the folder when you use just regular Windows Explorer. And this metadata may contain any kind of data. So in the very beginning, this NTFS ADS streams, they were used to, for example, to store information about the last scan by antivirus. So if this file hasn't changed since the last scan, so there is no sense to scan it again. I'm not sure if this technology is used until the present moment, but it was used before. And the most dangerous thing is that it is possible to store binary data, like any kind of data, into the stream. Like you can see here, there is a stream called bin. And this stream can be used as a source to create the process, as a source for process image. So you can, merely you can start a process from any ADS data, which is not visible in Windows Explorer and probably not scanned by antivirus solutions. And in this case, ransomware was put in this binary stream, and you can see in the Process Explorer, there is a join semicolon bin, which means this process was started from ADS. Another interesting techniques, a bit more complex, is using Windows Cache Manager, exploiting Cache Manager, I would weakness, not vulnerability, but weakness. The idea is Windows has a cache manager which allows mapping the files into the memory and performing operations in the memory, and then dumping this modified data into the file to reduce the amount of request to the disk when you need to, for example, to work with some specific file. When you open it in the editor and you perform multiple changes, operating system doesn't need to send this request to the file, but can make edits in the memory and then dump already edited file. Usually, this flow includes like a create file. Then we need to understand how big this file in order to map this file into the memory. So we need to allocate some buffer in the memory. So we use create file mapping and map view of file to map this file into the memory. Then we can work with this mapped copy of the file in the memory as with the original file. So we can modify this data. Then we call unmap your file. to delete this map file object. And when we call unmap view file, the data is dumped to the file on the disk. And finally, we close handle to the file, to the file map object, and close handle to the file on disk. That's how a regular flow looks like, and this is how it's implemented by Windows. But the attackers in WastedLocker, they implemented a bit different flow, which helped them to make these edits on behalf of the operating system. As you know, security services, they track any suspicious modifications of the file, especially if this modification is has a batch flavor, and they can block the suspicious behavior. In this case, all the modifications of the files, which means like encrypting the data inside of the files, were made by Windows. This is how it works. So the first part is the same. So the file is mapped to the memory. But then step number 5, they close the file handle, which means this file is not anymore attributed to the process that opened it. And then they perform encryption of the data in the memory mapped file. Then they call on map view file and close handle to the file map. After that, cache manager dumps all the modified data into the original file. But the problem is because the file handle was closed, this file is not anymore connected anyhow to this to the ransomware process, and this dump operation is performed by operating system, by Windows. So let's have a look. I recorded a small video just showing how it works. So this is a WastedLocker ransomware run in IDA disassembler. Currently, I am debugging this encryption process. So you can see the first step is it creates file, which means like create file API function is used to open the file and read the data. Then we map this file into the memory, create file mapping, and map view file. This is a second, probably step number 3. We got file size, we allocated buffer in the memory, then we call map view file. And on the right window, you can see that the content of the file appeared in the memory view. Then they call close handle to the file. You can see these operations in process monitor. And if we open the file, the file is being encrypted. You can see that the content of the file hasn't been changed. So we can still see some text in this file. What happened next? They actually start encrypting the file. They encrypted the file in the memory, and then they call unmap view file. And you can see in the memory on the right screen, on the right window, that all the data has been encrypted. And then we can open this file again in our file manager. And indeed, the data encrypted in the memory had been dumped to this file. But what's interesting for us is to take a look who is responsible, which process is responsible for dumping this data into the file. And now we will see it in process monitor. Just wait a second. Events, it takes some time until events come to the log and process monitor can view it. You can see that this operation performed by system process, which is actually Windows. So that's interesting case, and that helps to bypass the behavior blockers. Let's go back. And finally, ransomware. Not in all cases, ransomware is delivered manually by the attackers, but sometimes they collaborate with so-called first stage loaders or first stage Trojans, such as the trick, buzzer loader, and so on. So this, as I mentioned, this type of malware is called first stage loader. So they do not perform any malicious activity in terms of they do not encrypt, they do not steal data. Yes, sometimes they check cookies and sometimes they check your crypto wallets and the browser databases for hashed passwords. But the main purpose of these first stage Trojans is to get the command from the remote server and to deploy second stage malware or second stage Trojan, which is in our case ransomware, but it can be any financial malware like bank Trojans that targets some financial services to steal keys, crypto wallets, and so on. So this is how this cyber criminal ecosystem works. So and if we talk about ransomware attacks and ransomware as a service model, they also when they sell this ransomware code to affiliates, these affiliates they do not actually perform the attack by themselves, but they also can hire pen testers. I recently seen a very interesting publication when the attackers, like Russian cyber criminal group, they created a real company in Russia and they started hiring pen testers. And they do not tell these pen testers that they are going to like hack. They're not going to do like ethical hacking, but they're going to perform real hacking. And then in the description of the position, they say, okay, you will be provided access to the environment that you need to actually to test and to perform this penetration testing activities, collecting the keys, passwords, any sensitive data, and that's what this job is about. But one a security researcher applied for this position and he passed this interview, and he was provided access to the management console for running this malware, like a first stage Trojans malware. And he was asked to perform pen testing for some of the environment, but then he figured out that this environment is actually a real target, real not ethical hacking case, but real hacking case. So that's how it works, and this is because of this big payments that I would say help cyber criminals to build their businesses and make it more professional, create companies, train hackers, make this diversification of different functions between the teams, make this ransomware as a service model, or in general, like malware as a service model, when they also attract affiliates, and they pay, I believe, from 70 to 80% goes to affiliates, and from 20 to 30% goes to authors of the malware code. So this is like a real business, and they actually grow, and then the complexity of the malware is growing as well, because they have money, they can hire more people, they can hire more engineers. And recently, by the way, in Ukraine, our police, in collaboration with Europol, with the French police, and FBI, they caught the guy who was involved into creating ransomware. So he was not like a usual criminal that we got used to see, but he was just regular software developer, and he was hired to create a ransomware code. So to sum up, during this presentation, I showed you techniques used for initial access and delivery, which included supply chain attacks like Medoc, NotPetya, SolarWinds through Orion platform, exploited by Nobelium hacking group to deliver SolarGate or Sunburst backdoor. It wasn't a ransomware case, but still it used supply chain attack. Kaseya server exploitation of vulnerability in delivery mechanism of Kaseya server. Using the first stage Trojan, this is the previous slides, when the ransomware creators, they can collaborate with other teams and with other campaigns and get the compromised machine in order to deploy ransomware. Defense evasion, using digital signatures, disable Windows Defender, DLL side-loading attacks, or it's also, there is one DLL search hijacking, when when the attackers can place malicious DLLs in the same folder with the executable, which should load this DLL not from current folder, but from, for example, some system folder, from Windows folder. But because of this order of DLL searching, it loads the DLL first from the current folder. Alternate data streams, lazy writing, which is a feature of Windows Cache Manager. So that's it, and I'll be happy to answer questions.